Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a related rate problem. As per the problem, water is leaking out of an inverted conical tank at a rate of 10,000 centimeter cube per minute, and at the same time, water is being pumped into the tank at a constant rate. The tank has a height of 6 meters and diameter at the top is 4 meters. If the water level in the tank is rising at the rate of 20 centimeter per minute when the height of the water is 2 meters, find the rate at which water is being pumped into the tank. Let's start by drawing a diagram for this problem. We should draw an inverted conical tank. As per the problem, the height of the tank is 6 meters. The diameter at the top is 4 meters, so the radius at the top is 2 meters. Next, we should make the units for all numbers given in this problem the same. We are given that water is leaking out of the tank at the rate of 10,000 centimeter cube per minute. We can change this rate to meter cube per minute by dividing 10,000 by 100 three times, or we divide 10,000 by 1 million. Because 1 meter is equal to 100 centimeters, I get 0.01 meter cube per minute. Next, we can change the given rate 20 centimeter per minute to meter per minute. We should divide 20 by 100 because 1 meter equals 100 centimeter. I get 0.2 meter per minute. So as per the problem, water is leaking out of the tank at a rate of 0.01 meter cube per minute, and water is also being pumped into the tank at a constant rate. In this problem, we have to find that constant rate at which water is being pumped into the tank. Let's assume the constant rate at which water is being pumped into the tank is x. As per the problem, the water level is rising in the tank. That means the rate at which water is being pumped into the tank is greater than the rate at which water is leaking out of the tank. Let's assume at time t minutes, the volume of water in the tank is V meter cube. So dV over dt is equal to x minus 0.01, because x is the rate at which the water is being added into the tank and 0.01 is the rate at which the water is leaking from the tank. We are also given that the water level in the tank is rising at the rate of 0.2 meter per minute. Let's assume at time t minutes, the height of water in the tank is h meters. So as per the problem, dH over dt is equal to 0.2. We have to use all of this information to find the value of x. We should use the formula for volume of a cone to find the value of x because water that is added into this conical tank takes the shape of the tank, which is a cone. So we should use the formula for volume of a cone because that will be the shape of the water in the tank. The formula for volume of a cone is V equals 1 over 3 pi r square h. As per this formula, the volume of water in this conical tank depends on the radius at the top and the height of the water in the tank. In our diagram, we can show the water in the conical tank. At time t, the height of water in the tank is h. Let's assume at this time the radius of the water at the top is r. In order to use the volume formula, we have to do substitution for r in this volume formula because we are not given the value of dr over dt, we are given the value of dh over dt. So we want to write this volume formula only in terms of variable h. For that, we will use our diagram to find an equation for r in terms of h. We have to use concepts of similar triangles to find r in terms of h. We can label the corners of two triangles in our diagram. We will analyze triangles ABC and ADE. Both are right angle triangles. These are similar triangles. Triangle ABC is similar to triangle ADE as per the AA similarity rule because angle A is common to both triangles and both triangles have right angle at corners B and D. Since these triangles are similar, the ratios of their corresponding sides should be the same. That means AB over AD should be equal to BC over DE. The length of side AB is h, the length of side AD is 6, the length of side BC is r, the length of side DE is 2. We can isolate r in this equation on the right side. We should cross multiply 2 to the left side. I get 2h over 6 equals r. We can reduce 2 and 6. I get r equals h over 3. We can do the substitution for r in the volume formula. I get 1 over 3 pi. We should replace r with h over 3. Square of h over 3 is h square over 9. I get v equals 1 over 27 pi h cube. Now we can find the derivative of this volume equation with respect to t. On the left side I get dv over dt. On the right side 1 over 27 pi is the coefficient of the term. It is a constant. As per the constant multiple rule, it will stay the same. We can use chain rule to find the derivative of h cube with respect to t. We start with the power rule. We move the exponent 3 to the front of the term and subtract 1 from 3 in the exponent times dh over dt. This is the derivative of the volume equation with respect to t. Now we can sub in the values. On the left side, we can replace dv over dt with x minus 0.01. On the right side, we can reduce 3 and 27. I get 1 over 9 pi h squared times dH over dt. Next we can sub in the values of h and dH over dt. As per the problem, the water level in the tank is rising at the rate of 0.2 meter per minute when the height of the water is 2 meters. So we should replace h with 2 and dH over dt with 0.2. 2 square is equal to 4. 4 times 0.2 is 0.8. So I get 0.8 pi over 9. Next, we can move negative 0.01 to the right side of the equation. To isolate x on the left side, I get x equals 0.8 pi over 9 plus 0.01. We can evaluate this expression. I get x equals 0.289. Rounded to 3 decimal places, and the unit is meter cube per minute. This is the rate at which water is being pumped into the tank. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.